Hello there and welcome back to the channel. In this video I'm going to be doing a review of the new ZWO product, the Seestar S30 all-in-one smart telescope, which has just arrived with me this afternoon. ZWO have kindly sent me one so that I could try it out. It's the baby brother to the larger Seestar S50 smart telescope, which I've already done a review of if you look on my channel. The S30 is going to retail for £369 here in the UK and should be available from mid to late December. So I'm going to get it out of the box and see what's in here, and I'm going to connect it up to my smartphone, and then I'm going to take it outside on this amazingly clear night here in the UK and try it out and see what kind of imagery it can take. So let's get started. Okay, so let's pop it out of the box and see what we've got in here. Seestar, your handheld observatory. Got some instructions, some foam as always, protective foam, and here is the Seestar S30. So first impressions, it's a really solid, robust, well-built piece of kit on the face of it, certainly on the exterior. Got a nice big on-off switch there, a tripod mounting bracket at the bottom, a reset button, some sort of compartment there, a USB Type-C port. Yep, okay, so let's see what else we've got in here. There's also a black box to the side here. Let's have a look what we've got in here. Okay, so in here we have a solar filter and a USB Type-C cable. And then I suspect down the bottom we're going to find the little tripod legs for it. There we go. There's the tripod. Yeah, compact, but yeah, it seems to be nicely made as well. Metal legs. So I'll pop the box away and we can pop the Seestar onto the tripod. Like so. Spread out the legs and pop it there. There we go. Okay, so what I'm going to do is I'm going to connect this up to the USB Type-C and just charge up the battery so it's fully charged, and then I'm going to connect it to my phone. Okay, let's plug it in so I can start charging up the battery for tonight's session. You can see we've got two red dots there, which I guess is the charge level, and you can see it flashing on the second one there. So let's find the Seestar app on the App Store on my iPhone. I'll just type in Seestar. And there it is. And actually I've already got this, of course, from the S50, so I can just open the app. So now we're going to turn the unit on. Now to do this, we press a short press and followed by a long press on the power button on the front. And we'll just wait for it to boot up. I believe it's going to speak to me in Chinese. Okay, so now we will press connect, and it can see the unit, so I'll press connect. It says press the reset button at the bottom of the Seestar to confirm the connection. So I've pressed that. Activating, got it. Join the Wi-Fi network of the unit. Congrats, connected to your Seestar, start exploring. Okay, so we can start by just opening the arm. Hopefully we'll get some motion. Yep, the arm is coming up. And if I just turn the unit round a little, you should be able to see that it's got a protective cover on the lens, which I'm just going to remove. And that has the usual warning about not pointing it at the sun without the solar filter fitted. So maybe we'll go to scenery and we can just show how we can steer the unit around. We press this button and hold, and it should start moving. That's on slow, we'll go to fast. And there we go, the unit is turning left and right. And also up and down. Okay, that's fine. And you can see that it's got two cameras because it's showing the view from both of them. Presumably if I press this one, I see this one large and the other one small, and vice versa, so I can switch between the two cameras. Let's say I want to take a picture, I would just press the button and I've taken a picture. Okay, so far so good. I'm now going to allow this to charge up fully, and then I'm going to take it outside and give it a go. Okay, one thing I've realised is very important to do before I take this outside, other than to charge it up, is to calibrate the compass within it. If you don't do that, then the go-to function within it, which allows it to find things in the sky, won't work. So I just want to talk about the charging first. You can charge it off a regular USB cable. For example, I used an iPhone mains adapter with a USB Type-C cable, plugged it in, but it was very slow to charge. But I discovered from some communications with ZWO that if you use a 12 volt USB supply, so this is a mains adapter that produces 12 volts, 3 amps limit and a USB Type-C cable on the end. If you plug that in, then the unit will do what's called fast charging, and that charges much quicker. Now that's extremely useful if you're, say, running out of battery during a session, you want to boost the battery power and not take ages about it. That's really great. But there's another good thing about it as well, and that is that I've found that if you run off of a regular cable, which is 5 volts, then if you try and operate the unit and charge it at the same time, it'll still discharge the battery quicker than it's able to put energy back in. But with the fast charging at 12 volts, that's not the case, and the battery will charge up even when you're operating the unit. And that means that if you run an extension lead out the back of your house, for example, and you plug in your 12 volt supply, you will not run out of power, you will not have it shut down, you can use it as long as you want to, which is a really great thing. So that's really worth knowing. So that's the charging. As you can see, if I press the button just once quickly, I've got 4 red lights now, which means I'm 100% charged. So that's the charging part of the story sorted. Now what I need to do is calibrate the internal compass. Okay, so to do the compass calibration, we turn the unit on, which I've already done, and press connect on the app, choose connect on the device as well, then press join, and after a few seconds we'll be connected to the unit. We can press start exploring. Now we press the picture of the unit at top left, scroll down to advanced feature and look for calibrate, press that, and we're looking for compass calibration, and we press calibrate there. It gives us a little video demo of what we're going to need to do. I press calibrate, and you now see we have this ring with a little bit of green on it, and I'm now going to rotate the unit nice and slowly, a full 360 degrees on a flat surface. All the way around, and you see that the ring fills in green as you go around. And that's pretty much where I started. So I just check on the app, and indeed it says calibration is complete. So I press complete, come back out of this menu and back to the top level, and the compass calibration is now complete. So now it's time to take the unit outside into my back garden. I'm going to place it in the middle of my lawn where it's got a reasonable view of the night sky. Try and pick a reasonably level spot to place it, and then press and hold the power button to switch it on. I can now head back indoors and operate the unit from my mobile phone from a nice warm cozy place. Okay, so the unit's turned on. I'm going to press connect and connect and join. And start exploring. And first thing I'm going to do is go into stargazing, and these are the catalogues, but I'm actually going to skip the catalogues and go straight to here, which is actually the view of what it can see. Now, at the moment the arm is closed, so in fact we might go back and just open the arm so it's actually pointing up in some way, perhaps at the sky. So we'll just let it open. You can see just here that the battery is 100%. I've actually got it connected to a 12-volt charger, so it should stay at 100% the whole time. So we'll just wait while the arm opens. And now I'll go back to stargazing, skip the catalogues and go into Sky Atlas. Now if I zoom out, we can look at the whole sky. I've got the ground turned on. If we turn that off, you see the full sphere below and above, but we're just interested in what's above the horizon. There's some cloud out there and houses and trees in the way, so I'm going to look at something that's fairly high up. At the moment, I want to look, perhaps, let's go up to Andromeda. That's nice and high up in the sky. So let's zoom in on Andromeda. And I can position myself on that and press Go To. Now hopefully it will succeed in finding Andromeda, provided those clouds haven't come in. You can see the blue rectangle moving across the sky towards the red rectangle. If we zoom in, you'll be able to see that more clearly. So what it'll do, it'll move to where it thinks that is in the sky, and then it'll take a picture and compare it with its own database, a process called plate solving, to see if that's where it really is pointing. And so long as it can see some stars and it's reasonably well focused, it will be able to figure out where it's pointing, and that's where it's actually pointing. So now it's making a correction and moving from that position to where the Andromeda galaxy is. And now it should be much closer. So it'll take another picture and just compare that again with the database. And it's making another fine correction, so it must be getting pretty close now to pointing at Andromeda. Okay, it's happy. So now that it's done that, it's doing an initialization. So it's doing a horizontal calibration. So it actually steers 15 degrees to the left and to the right of the target, looks at what's in the sky, and it can work out how far off horizontal and in what direction it is actually mounted. I've just put it on the lawn, so it's not a perfectly horizontal bit of ground that it's on. So it's a good thing that it does this calibration, because it means that it can track more accurately. So we'll just allow that to finish. We're 60% complete, 80%, 90%. So it says that that's successful. So it's now moving back to point at the target again. Okay, now it's content that it's pointing at the target again. It's now preparing its image enhancing capability. And 100%. Okay, now it will do an autofocus. So it will change the focus over a number of different positions and look at how small and sharp the stars are, and then figure out from that set of positions and that set of sharpnesses of stars where the optimum focus position is, and then it'll put it in that position. So this is an important step to make sure that you are well focused, which means you get the best detail in your images. Doesn't take too long. Okay, so there's our view. We're focused and it's now taking photos. And you can see this bright blob in the middle here. That's the core of the Andromeda galaxy. It's just taken its first 10-second shot, and it will enhance that and then add it to the stack. So that's our first photo. And now it's taking a second shot. And you see at the top right hand corner here, that's gone up from 10 to 20 seconds. So that's now a stack of two 10-second shots. And what I'll do, I'm just going to let this run for 1 minute. And then I'm going to show you slewing to a different target. And I've already actually acquired a much longer stack of the Andromeda galaxy, which I can show you later. So I'm more interested now in showing you how to operate the unit rather than that what the final results are, which I'll show you a little bit later on. So we're up to 50 seconds. I'll let it just do this last one. So we've got 1 minute's worth of stacking. Sometimes it will actually reject frames if it thinks there was maybe an aeroplane went over, or the tracking wasn't perfect and the stars have shifted during the exposure. So you've got some star trails. It will reject the frame and won't add it to the stack, so it doesn't spoil it. Okay, I'm going to hit stop, and it's going to take that as its final stack and store it. So if I click on the button at the bottom left here, I can go into photos that I've previously taken, and there is the shot that I've just taken 1 minute on the Andromeda galaxy. Okay, so far so good. So now what I want to do is go back to the Sky Atlas and choose a different object. Now I could zoom around with my fingers and look for something, or I can use the objects database. If I go into the database, we've got these current best targets. So it's showing you a number of things that it believes are up in the sky at the moment from where you are, but it doesn't know about your local obstructions. So if you've got trees and houses in the way, it won't know about those. So it's no guarantee that those things will really be visible. But if you're in a nice open place with a clear view to the horizon in all directions, it's pretty reliable. So I'm going to go to nebulae. And you notice it says current altitude 83 degrees, 80 degrees, 79 degrees, etc. So this is helpful in trying to find something that's in a good place. Let's try the Heart Nebula, and let's have a look at where that is in the sky. So this is the Heart Nebula, and it looks like that's 90, 80, 70 degrees up in the direction. That's east, and that's north, so it's sort of north, northeast, 70 degrees up. I've lost it there, so I'll just go back into nebulae and find it again. There it is. Okay, and we'll do a go-to on that. Hopefully it will be able to move to that. I think it has to spin all the way around in azimuth in order to be able to image that. So it's going to take a little bit of time for it to get round there. But you can see it doing its thing and finding its way around to the Heart Nebula. Now this is definitely a target where the light pollution filter is probably a good idea to enable. So once the go-to has finished, I'm going to turn on the light pollution filter. Okay, that's quite a big move it's made to get there, so its error will probably be quite large. So it's taking a shot to see where it's pointing, and we'll see how far off it really is. Oh, actually not very far off at all. Okay, that's good. Okay, now I'm going to turn on the filter. This is just here. So I'm going to stop that. I'm going to switch on the filter, and we will start taking pictures. And let's see how this one builds up. So that's our first 10-second shot, and we can already clearly see some red nebulosity in the background, behind the stars if you like. So that bodes well. We'll leave that running and watch that build up for a little while. The first minute can be really rewarding because you get that doubling from 10 to 20 seconds and again to 40 and again actually to 1 minute 20. So we'll wait until we've done 1 minute 20, and then I'll leave it until we get to about 10 minutes and come back to it and see what it looks like. But this one might be a good one to leave for maybe an hour or so. That's 40 seconds. And 1 minute. Okay, so I'll stop recording there, but I'm going to leave it shooting and come back when it's done significantly more time than 1 minute. Okay, so we now have 20 minutes of exposure time on the Heart Nebula, and you can see we're getting more and more signal to noise ratio, lots of nebulosity showing up here. One of the things that happens with these types of telescopes, which has a sort of rotation on the base called azimuth, and then the elevation of the arm moving. It's called an alt-az mount, and as it tracks the night sky, it has to rotate, and that causes effects when you're stacking at the edges, and you see that up here at this corner, and you'll see it also down the bottom right hand corner. You see it looks a bit noisy and strange, and that has to be cropped out at the end of the day, unless you actually mount it on a thing called a wedge, so that you're tilting it by your latitude angle and turn it into an equatorial mount. So yeah, it does limit how long you can stack for. The longer you stack for, the worse that effect will get on the edges. So we're just approaching 21 minutes of exposure time there, so that's quite a good demonstration of imaging a nebula. So we'll stop there and change to another target. So I'll hit stop, and we're going to go to solar system, moon, go gazing. So we'll skip the go to, and you can see we're already pointing at the moon, which is fine. And I'm going to take a photo. There we go. And if I want to, I can do switch to 2 times, get a bit more zoom going on, and take a photo. And you see these photos are going into the saved images area. So there's the image I've just taken of the moon. So that works really nicely, but you have to be careful how you go to the moon, otherwise you end up with an overexposed image. And just as a reminder, from the top level menu we need to go into solar system, and don't go into sky atlas, objects, moon, because that won't work properly. Go into solar system, moon, go gazing. There we go. I'll skip the go to because I know I'm already pointing at it. Good. So that's worked really well. Incidentally, if the moon wasn't in your shot, you could switch to the wide angle camera and then just literally steer it around like this until you get the moon centered, and then once you've got it centered, you could switch to fast to move faster, or slow to make fine adjustments. And then once you've got it centered reasonably well, like, let me just get it reasonably centered. That's pretty good. Now I can switch cameras, go to 2 times. That slightly wants moving, doesn't it? Just wants adjusting a little bit. Bring it up a bit. Looks good. Let's take another photo. If we want to, we can adjust the exposure by hitting this plus minus. We can just reduce the exposure a little bit. There's maybe a little saturated around this crater here. So I'm just going to take it down a bit. That's too far, clearly. Minus 65 maybe. That looks nice. And take a photo. Excellent. What I'd really like to do is image the Great Orion Nebula. Let me just go out and check if it is visible above the hedge. Okay, and now we can go to the sky map and see where we're pointing. There we go. So there's M42. We can do a go-to on that. Here it comes. And honestly, M42 is one of the best targets to start with, and it's a winter target here in the Northern Hemisphere. So if someone gets this for Christmas in the Northern Hemisphere, they're going to have this target to have a go at when they get a clear night, which is a really super one. Very bright nebula, lots of interest in it. I think actually the catalogues recommend having the filter on for this target. Personally, I think it's better with it off. So it is a personal choice. And it's now starting to take pictures. But I don't like the way it's aligned, so I'm going to stop it. I'm going to go back to the Sky Atlas. I'm just going to change the way it's framed. I prefer it like that. So I'm going to hit Go To. And it's reframing the object. There we go, and now we're back to imaging again. Great. So we'll get our first 10-second frame on the Great Orion Nebula. Oh dear, that's not so good. Now I think it's probably rejected that. Now this happens sometimes after a slew, because it is taking up the backlash in the gearing, but it's rejected that frame, taken another frame, and that one's good. So it looks like the backlash has gone and we're in good shape. We've got one 10-second frame, now we've got two, and now we can see it starting to build up an image of M42, the Great Orion Nebula. It really is the most awesome nebula. It's so bright. It's a really beautiful thing. And it's actually the Demiron's Nebula here. It's very bright core. There's sort of bluish stuff all the way around here, and then red in here. And then there's another nebula up here called the Running Man Nebula, which you can just barely make out here, but that's only 40 seconds of imaging. So as we allow this to build up, we'll see more and more detail appearing. However, it is very low in the sky at the moment. I think you can actually see there's some sort of washed out nature to the sky, particularly at the bottom of this shot, and that's because of the moon and the proximity of the Great Orion Nebula to the moon that's causing problems here. If I did this on a different night when there wasn't any moon in the sky, the background would be much darker and you'd be able to see fainter details. But in any case, we'll let this run for a little while just as a demonstration of what's possible, and I'll come back when I've got maybe 10-20 minutes of data. Okay, so we've been going just a little over 30 minutes now, and we can take a look at what we've got. Incidentally, these four little arrows at the top, if you press them, it hides all the buttons so you can get a clearer view of the image. So we can zoom in on that. Oh, it's looking really nice. Hopefully up here we can see the Running Man Nebula. It's a bit hard to see the outline, but it is kind of in the shape of a man that's running. So that's looking really good. That's half an hour on M42, the Great Orion Nebula. Okay, I just want to talk a bit about looking at planets with the Seestar S30. Planets are extremely small in the sky, and although some of them are very bright, like Jupiter, Saturn and Venus, you can't expect to see much detail on such planets with a Seestar. You really don't have enough focal length. Typically you want something like 4,000 or 5,000 millimeters of focal length, and we've got 150 millimeters. So that's the important thing. But we can see the disk of Jupiter and some of its moons with a Seestar, and we might also see that Saturn is not just a disk, that maybe it's got some kind of ring system around it. Okay, so we're going to go into Solar System, select Jupiter, and it will now move the telescope to find Jupiter. You can see how many degrees it is away, and it's getting pretty close now. Now it's getting ready to show us the image. Okay, it's done a good job there of finding it. I'm going to increase the exposure. And I'm also going to zoom in 2 times. Now I'm increasing the exposure because I want to see the moons. There we go. I can see some moons going on there. That's good. So let's just take a photo like that. But I'm then going to actually zoom in 4 times. See if we can really see the disk of Jupiter more effectively. Cool. So we can see at least, I think there's 2 moons there and 1 here. So let's just take a photo there. And now I'm going to drop the exposure and see if I can get the disk of Jupiter to not be saturated like that. So if I drop it down, let's start at 0, close to 0, see what that looks like. The moons will pretty much disappear. I can vaguely see them. No, it's not enough, so I need to go down more. Let's go all the way to the bottom and see what it looks like. Yeah, so it's not saturated anymore, that's good. That means that somewhere in between we might actually be able to see some suggestion of the cloud bands on Jupiter. Let's take a picture there and go to the gallery and take a look at it. Whoa, okay. I think we're pushing our luck a little bit with this telescope to expect to see detail on the surface of Jupiter. So again, it's important to understand what you can and can't do with this telescope. So let's go back up to maximum exposure. And I really like the fact that we can see some of Jupiter's moons here. So I'm just, oh, I've scrolled a bit too far. Let's just come back a little. That's fine. So we've actually got 4 moons there. Let's take the picture. Let's go and have a look at that photo. And you can see there's Jupiter, 1, 2, 3, 4 moons of Jupiter. I've got an app on my phone, I can look up and see which ones they actually are. But I think that's quite cool for a little telescope to be able to see Jupiter and 4 of its moons like that. Okay, so it's the next morning and the sun's shining, so I've put the unit outside in the sunlight. I've connected to it and I've done open arm and fitted the filter. So now what we need to do is go solar system, sun, go gazing, and I'm going to skip the go to and observe. We've got the 2 views, so I'm going to go to the wide angle view. Actually, it's not far off at all, so I'm just going to move to the right a bit. And we're obviously watching the other view. There we go, that's pretty good. Then we can switch views, just make some fine adjustments to the position. That's good. And now I'm going to do enable target correction to keeping the center, keeping the sun centered. I'm going to switch to 2 times magnification. And we can take a photo. There's a little bit of cloud in front of the sun at the moment. You can see some sunspots down here. I'm just going to let that cloud just clear for a moment. Let's just adjust it slightly so we get the whole sun in the shot. A little bit more. That's fine. Okay, so now we can take the photo. I can adjust the brightness if I want, make it a little bit brighter. That's too much clearly. +10 maybe. That looks pretty good. It's actually drifting off a little bit. Okay, and I can take my photo. And one more. Got some nice sunspots down here. Let's take a look at the picture now. There's the photo. Yeah, we can see some sunspots on the sun. Not as clear a sky as I would have liked, but it shows you the principle of how you can image the sun in the daytime. I want to finish up by showing you a gallery of images that I've taken with the Seestar over the last couple of nights, starting with Andromeda here. I think this is an amazing piece of kit, especially now that it's so small compared with the S50. It's so much more portable. It's also a lower price, and it brings the ability to do astrophotography, if you like, to the masses. People who've never done this before, don't want to spend an absolute fortune, but really want to get out and image the night sky and experience the wonder of what's above us every clear night that we don't normally see. It's a super thing to show your friends the pictures you've taken and go, wow, this galaxy, the Whirlpool galaxy for example, is over 20 million light years away, and yet we can get an image of it like this from our back gardens. If you've enjoyed this video, I'd really appreciate a like, and if you haven't already subscribed to the channel, please do so. If you want to buy a Seestar S30, it would really help my channel if you wouldn't mind using the affiliate link in the description. It won't cost you a penny extra, and it means I get a small commission to help me make more videos like this. Thanks for watching, and clear skies.